Greetings, fellow coding explorers! Today, we're taking another look at for loops. We will begin by exploring a clever way to keep track of those repetitions without manually counting them. We'll also look at how to use conditional statements within loops, as well as how to use the range function in a new way that lets us count from one specific value to another. Let's jump into counting with loop variables. As you know, for loops are great for repeating a code a certain number of times. If you want to count how many times a loop executes, you might think that you have to add a counter variable within the loop and add 1 to it each time the loop is executed. But did you know that we can use a counter variable right inside our loop that tells us the current value of our range function? Take a look at this code. We have replaced the underscore with a variable. This variable can be named anything, but the standard for loops is to use the variable named I. If we add a print statement inside this for loop, we will see something interesting. Look at the output when this loop runs. Is that what you expected? Most people begin counting at the number 1, but computers often begin counting at 0. So range 5 does run 5 times, but it begins counting at 0. So our value of I is 0 on the first iteration. We can say that the range function with x as the parameter begins counting at 0 and ends at 1 less than the value of x. This variable can be said to be exclusive, meaning it doesn't include that number in the count. But what if we don't want to start our counter at 0? Well, it turns out there is a second way to call the range function. This one accepts 2 parameters. The first parameter is the number where you want the range to begin counting. And the second parameter is 1 more than where you want the range to end. This second number is also exclusive, meaning it won't be included. For example, if we wanted to begin our counting variable I at 1 and end at 10, we would write for I in range 1, 11. Remember, the range function stops at 1 less than the second parameter, so that is why we need to use 11 in order to stop at 10. What will this print to the screen? Wow, this time the numbers start at 1 and end at 10. This is a much more human-friendly way to count. Now, it's your turn to try. Write a loop that prints the numbers from 5 to 14. Pause the video here and give it a try in your guided notes. This is how your loop should look. For I in range 5, 15, print I. This will successfully print the numbers 5 through 14. Now that we have a way to alter where we begin counting and end counting, let's consider a scenario where we must print only the even numbers from 1 to 10. A for loop with a conditional statement allows selective execution based on the specified condition. In this case, even numbers only. We also want to alter our range function to start at 1 and end at 10. We can use the same for loop that we created earlier, since our range is the numbers 1 through 10. Then, inside this loop, if we wanted to only print out the even numbers, how could we do that? Here's a hint. You will use an if statement with the modulo operator. Pause the video here and try this on your guided notes sheet now. For this problem, we will first check if I modulo 2 is equal to 0. If this is true, it means that the number is even. So we print the number. Great job! This example demonstrates how integrating conditions into loops enables selective processing, enhancing the loop's decision-making capabilities. Now it's your turn. Can you write a for loop that starts at 8 and ends at 20, only printing out the numbers that are evenly divisible by 4? Pause the video here and try this on your guided notes sheet. Let's check your work. We start with a for loop with range 8, 21. Remember, this second parameter is exclusive, so we enter a value that is one more than where we want to end. Then, inside the loop, we use the modulo operator to check if the number is divisible by 4. If it is, we print it. Let's take a look at our programming task for today, which involves storing all of the delicious fruit we have harvested. Our team has successfully harvested a bountiful supply of delicious fruits, and now it's up to us to store them in the fridge to keep them fresh. Our fridge on board has 14 zones, numbered from 0 to 13. Our mission is to fill the entire fridge with these fruit boxes. To navigate through this challenge, we have a handy tool called Put Zones. This command allows me to place a fruit box inside the fridge at a specific zone. For example, if I want to store a box in zone 3, I'll simply use Put 3. Our fridge is designed to accommodate as many fruit boxes as there are zones, meaning we'll need to fill all 14 zones to complete our mission. The order in which we decide to load the fridge is entirely up to us, but remember, we must fill each and every zone. Now, instead of placing each fruit box one by one, we can use a for loop to make this task easier and more efficient. Be sure to use the correct range function when you loop. So, who's ready to take the first step and use a for loop to place fruit boxes into the fridge? We've embarked on an exciting journey through the world of loops and counting mechanisms. We've explored loop counters, which allow us to keep track of repetitions. By using loop counters, we can efficiently manage repetitive tasks. We've also seen how we can combine conditions with loops. This enables us to execute code selectively based on specific criteria, making our loops more versatile. Lastly, we've further explored the range function, a valuable tool that, when used with 2 parameters, provides precise control over where our loops start and end their counting. This let us tailor our loops to specific ranges. You're now well equipped to tackle a wide range of coding challenges, from repetitive tasks to complex decision-making within your loops. Remember, coding is not just about writing instructions, it's about writing intelligent, efficient, and adaptable instructions. Be sure to complete the programming tasks, practice questions, and extension activities before moving on to the next lesson. And remember, in the universe of coding, the possibilities are infinite. See ya.